So which of the following statement is true? F of x is equal to x square plus 3 when x is not equal to 0, 1 when x is equal to 0. Is it continuous and differentiable at x is equal to all real number? You know, it's in a parabola. Definitely at this point it will not be differentiable. Differentiability means you should be able to do a slope. You can do slope for left hand side, right hand side, not at this point. So this is x square plus 3 is definitely an upward parabola, and you know at 0 it is definitely not differentiable. So it is continuous and differentiable for all real numbers other than 0. So option number C is the right answer. So draw the graph and see and justify an answer. So let's go to, this is how board paper will be. I am typically doing a board paper. Okay, these questions are from self-study site. So f of x is continuous on close bracket a comma b. A graph is continuous on a comma b and differentiable an open bracket a comma b, which means you can do a slope between a and b. Every point is differentiable. Then they've also given that it's strictly increasing. If it is strictly increasing, the graph has to be like this. If it's differentiable, you can do a slope opposite by adjacent at every point. It's also continuous. Increasing means decreasing means negative slope. So the fact that it's increasing shows that it's a positive slope, and therefore the f dash of x has to be, the slope has to be greater than 0 positive slope and x is lying between a and b. So option number B is the right answer. So you understood what is a negative slope and a positive slope from this. The negative slope is not applicable because strictly increasing means a positive slope. So let's go to next question. F of x is equal to x square into mod x. Let's redefine this function because we have to check if it's continuous at x is equal to 0 or differentiable, sorry. So you're going to approach 0 from the left, minus x cube, less than 0 is minus x cube, greater than 0 is plus x cube, because mod function will get redefined as minus x and plus x. So at x is equal to 0 is 0. So then you're going to approach this sum. Okay, I have to do this sum now. Basically you need to know what is differentiability to be able to do this. So I'll teach you the basics of differentiability and then continue to do the sum. Let's take this point here, 1. If you're going to find whether it's differentiable at 1, for continuity it will come from the left and come from the right, and write x is equal to 1 minus x and x is equal to 1 plus x. For differentiability, you have to come slanting, because you're going to see if it's a slope, if it's possible to do a slope, whether the slope is equal to this slope is what you're trying to do. So what is this? This is h, and this point will be 1 plus h, and if this is h, this point here will be 1 minus h, and this function, this y value here can be f of 1 plus h or f of 1 minus h, depending on which point we are taking. So slope for this is opposite by adjacent. Opposite is f of 1 plus h minus f of 1 by adjacent is h. So the formula for the right hand limit you all should know is f of 1 plus h minus f of 1 by h, limit h tends to 0 is the formula for right hand limit for f limit of f dash of x. X tends to 0 from the right. For the left limit, it's f of 1 from this to this. So 1 minus f of 1 minus h. So f of 1 minus f of 1 minus h by, the gap is just h again. And this is a limit of f dash of x. X tends to 0 from the right. Are you clear? Thus we have written the two formulas for the left limit and right limit. So supposing if you have a point A, let's see how to write a general formula. It's like, okay, what is A? It's f of A plus h minus f of A by h is the formula for right hand limit. What is the formula for left hand limit? F of A minus f of A minus h by h. Limit h tends to 0, and here also h tends to 0. You understood the formula? Differentiable means you have to come slanting. So if both the slopes are the same, then it's differentiable. It's very simple. Left hand side slope and the right hand side slopes are the same, then it's obviously differentiable, means at every point. See, if the graph is like this, here also slope is same value, here also slope is same value, which means at this point it is differentiable. But in the case of this, you see the slope is plus and the slope here is minus. At this point it's definitely not differentiable. So that's what it means. So coming back to what I was doing, you're going to approach 0 from the left like this and 0 from the right like this. So for the right limit, the formula is f of 0 plus h minus f of 0 by h, limit h tends to 0. And for the this is for the right hand limit. So that's 0 from the right. Correct? No, you don't have to put that because right hand limit is there. For the left hand limit, what is the slope? F of 0 minus f of 0 minus h. That's all. Don't write h or anything there. It's minus h. So just write f of 0 minus h by h. Let's keep it as h only in this. So then limit h tends to 0. What is f of 0? F of 0 is 0. What is f of 0 minus h is less than 0's formula, which is minus x cube. So it's 0 minus h the minus h cube, which will make it plus h x cube, and h x itself is 0 minus h the whole cube by h, which is minus h cube by h, which is minus h square, and limit h tends to 0. Limit h tends to 0, and therefore the answer is 0. Let's look at the right hand limit. F of 0 plus h is greater than 0's formula, which is plus x cube. So it will become h cube. 0 plus h the whole cube. Correct? Which is h cube minus f of 0 is 0 by h, which is h cube by h. Answer is h square. Limit h tends to 0. The answer is here also 0. And the left hand slope is equal to right hand slope, and hence it's differentiable at x is equal to 0. That completes this sum. It's a superb sum. You understood what is differentiability because of it. So let's go to fourth question. This is not only differentiability, it's got all other sums which I'm doing. If y is equal to root of tan of root x, prove that root x into dy by dx is equal to 1 plus y to the power 4 by 4y. So this is what is given. Whenever they give like this, and there's root x, no, so we can consider it as either do it as it is, considering the capital X, y is equal to root of tan root x. You can consider this itself as a capital X and write 1 by 2 root x. So dy by dx itself is 1 by 2 into root of tan root x, and tan root x differentiation is secant square root x, and root x differentiation is 1 by 2 root x and with the multiplication symbol. Correct? So therefore what is dy by dx is secant square root x by 4 root x root of tan root x. The root x is brought to the left side. Can you see? So then in the prove that, so root x into dy by dx therefore is secant square root x by 4 root of tan of root x. But what we need to prove here is with y. Y is in the question. Root of tan of root x is nothing but y. So you can substitute this as y. And secant square theta is 1 plus tan square theta. So you can write it as 1 plus tan square root x by 4 root of tan root x. And you're going to write this as y. So it will be 4y. And this will be 1 plus y to the power 4 avada. Tan square, no? This has been squared, that's all. And there's one more square. Root is also gone. With the root only, the question is. So would it be y to the power 4? Yes, correct. So y to the power 4. Such an easy sum, root x into dy by dx. We have never done such a sum in differentiation. We are just including extra sums. Again, it's not just differentiability. There's more to it, correct? So let's go to more sums. Okay. So let's go to more sums. I just want to do some selected sums for now. So next question is about the differentiability. Back to the topic that I wanted to do. The question is differentiate. Now, if f of x is equal to x into greatest integer function. No, just mod x. You can redefine the function. For all x is an element of R, check its differentiability at x is equal to 0. So you have to check differentiability at x is equal to 0. So redefine the function. F of x will be minus x square when x is less than 0, and 0 when x is equal to 0, and x square when x is greater than 0. Correct? And let's do a differentiability at 0, similar to what we did. You're going to upload 0 from the right and 0 from the left like this, and you know the formulas are. The formula for the right hand limit, tell me, f of 0 plus h minus f of 0 by h. Don't write minus h or anything there, because let's mark up the formula. Left hand limit is f of 0 minus f of 0 minus h by h. Both the places like limit h tends to 0 and limit h tends to 0. What is the formula for f of 0? 0. And f of 0 minus h means less than 0's formula, which is minus x square. So it's 0 minus minus of 0 minus h the whole square. Minus of 0 minus h the whole square by h, correct? Because this minus is already there. 0 minus h means
0 minus of minus h.
The minus of minus.
0 minus of minus h.
Yeah, minus.
That's right.
Okay, because f of x is minus x square. F of 0 minus h will be minus of 0 minus h the whole square, which is minus of h square only. We'll still get it as positive, minus of h square only. Okay, so then therefore this will be minus h square. Let me underline, this will be minus h square, and with this minus it will become plus h square. Plus h square by h. So answer is limit h tends to 0 is as 0. Let's go right and say 0 plus h. 0 plus h means x square. So which is 0 plus h the whole square. Minus f of 0. What is f of 0? Is just 0 by h. Okay, so it's h square by h is it's again h. So limit h tends to 0 is again 0. So the left hand limit is equal to right hand limit. I'm just thinking this is okay. Let's see what. Let's practically think about this sum. Okay, just want to practically think. So look at this. This is minus x square, which is an inverted parabola. Plus x square is an upward parabola. Both of them will not be differentiable at this point, which is at 0. And it's definitely a continuous function. If you see this, I can draw this. So 0 is equal to 0, which shows that it's differentiable. It's differentiable at x is equal to 0. But you might ask me, in practical life, auntie, this is an upward parabola and one is a downward parabola. And how can you say, you just now told that the upward parabola, this point is not differentiable, you can't do a slope. Which means here also you can't do a slope. They are treating this as an ogive. Can you see this upward parabola? This is an ogive. So you can do slope, 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 slope. You can do everywhere. If it's an ogive, you can do it, correct? So then don't think of it like a parabola. It's an upward parabola, downward parabola together constitute a fact that it's differentiable at x is equal to 0. Very complex, isn't it? So then let's go to next question. So there's another sum here where it's a protein sum, whatever the sum number is. I'm taking from some book. So f of x is equal to, okay, open a bracket, x square for x is less than 1 and 2 minus x for x is greater than or equal to 1. One is a parabola, other is a straight line. Okay, so we just have to see where it's not differentiable. It will be continuous. We have to see. Let's check the continuity. Actually, no, I'll teach you a trick for differentiable. Okay, take the left hand limit and differentiate it 2x. You know differentiation, right? Substitute x as 1, you get 2. Take the right hand limit and differentiate it. You get minus 1. So 2 is equal to is never equal to minus 1. You differentiate, you get a slope, no? So left hand slope is not equal to right hand. But they won't give you answer if you write like this. They won't give you marks if you write like this. So it's sad. Because differentiation means you do the slope of that. Differentiation means slope. Left hand slope is equal to right hand slope. You know, as you see, you know that it's definitely not equal. You know, it's 2 and here it is minus 1. 2 is not equal to 1. You know the answer. But you have to do this. So how do you do that? Okay, let's do it for differentiability, not continuity. Okay. So sometimes when it is not continuous, the graph itself is not continuous, it will not be differentiable.
Oh, yeah.
But here they will say, okay, let's do continuity for that matter. Limit of f of x. X tends to 1 from the left. What is the formula? X square. Limit of f of x. X tends to 1 from the right. It's 2 minus x. I'm doing continuity. So direct substitution is 1. Direct substitution here also is 1. So left hand limit is equal to right hand limit. It is definitely continuous. There's no doubt. When it's continuous only, you can check differentiability. If it's not continuous, every continuous function may be differential. But every differential function is definitely a continuous function. We understood this. So let's see differentiability now. So let's do differentiability at 1, right? So you're going to approach 1 like this and 1 right? So the f of 1 plus h minus f of 1 by h, and you know it's not differentiable. You know the answer itself because I taught you a shortcut. So now left hand limit is f of 1 minus f of 1 minus h by h. and both the cases limit h is tending to 0. So let's substitute when in 1 less than 1's formula is x square. At that point formula is 2 minus x. When you substitute 1 here, 2 minus 1 is 1. So at that point answer f of 1 is 2 minus 1, which is 1. So you know that f of 1 is 1 minus f of 1 minus h is less than 1's formula, which is x square, which will become 1 minus h the whole square by h. Limit h tends to 0. So this will be, you can take it as a plus b into a minus b, putting a square, 1 plus, or you can just do direct substitution. You don't have to do all that because it doesn't matter. It's just direct substitution. Numerator will become 0 by h, which will be leave it like that. Let's go to the right hand side. 1 plus h. What is 1 plus h greater than 1's formula? It's 2 minus h. So 2 minus x bala 1 plus h. 2 minus x. X becomes 1 plus h here. 2 1 plus h minus f of 1. We know the answer is just 1. This is whole thing na? Minus 1 by h. Open this bracket. 2 minus 1 will become 1. 1 minus h. Minus 1 by h. 1 and minus 1 get cancelled. Here limit h tends to 0. Here you know definitely 0 by h. Here you have h by h. Minus h by h, answer is minus 1. Whereas here it's 0 by h. Just leave it like that. Don't even think, because this is 0 by 0. You don't know what to do. So I would write it as 0 by h is not equal to minus 1, and so it's not differentiable, which you already know. How do you know? Shortcut. Differentiate left side, you know, 2x. Substitute direct substitution 1. So answer is 2. Left right hand side differentiate minus 1. You already know by verification, and you're doing this method. Are you clear? So let's go to next question in this. So let's go to next question. The sum that I want to teach you is this 36-second sum. This show that the function f of x is equal to mod x minus 1 plus mod x plus 1 for all x is an element of real number is not differentiable. Is not differentiable at x is equal to minus 1 and x is equal to 1. You know the cutting points here, 1 and minus 1. You know how this graph will be? At 1 and minus 1 there will be a v like this and a v like this. In fact, we did it with the assignment sheet also. So this is how the graph is. Okay, and you know that at this point you can't do a slope. At this point also you can't do a slope. In practical life, you know, at that slope means you should be able to write opposite by adjacent. So you know for the fact that from this graph itself, but we cannot justify using that. We have to do the sum. So how are we going to do it? Okay, so 1 second, hold on, I'll just do the sum. So when a function like this is coming for your exam, which is f of x is equal to a mod of x minus 1 plus mod of x plus 1. The cutting points are 1 and minus 1. Now redefine these functions. Redefine this function. How to redefine the function? You know, when it's less than minus 1, take this function, take this function x minus 1. When x is minus 1, in the book, minus 2, example put it, this will become negative. This whole thing will become negative, whereas this whole thing will also become negative. So both these functions are becoming negative. Correct? Give one example and see. You understand that when it's less than minus 1, this is also negative, which is minus x plus 1. This is also negative, which is minus x minus 1. 1 and minus 1 get cancelled, minus 2x. When it's less than minus 1, you got a new formula where f of x is equal to minus 2x. Between this and this, give an example, 0. This is negative. The first term 0 minus 1 is negative. 0 plus 1 is positive. So 1 is negative, other is positive. Write the formula minus of x plus minus x plus 1 plus x plus 1. X and x get cancelled. The answer here is 2. So now greater than 1, what is the example? 2. You can give 2, positive and positive. So then therefore it's 2x with 2x. So then you can redefine the function like this. Write a bracket. When x is lesser than minus 1, the function is minus 2x. When x is lying between minus 1 and plus 1, just put an equal to symbol here in between. Somewhere you have to equate. No? So this and this let's include and write it as 2. And when x is greater than 1, it's 2x. So you redefine the function, you got it. Now you can do the differentiability, correct? So you're going to approach, less than 1, greater than 1. Less than minus 1, greater than minus 1. So you have to do a graph where there's minus 1 also, there is plus 1 also. So you're going to approach the 1 from the left, minus 1 from the left and minus 1 from the right, plus 1 from the right and plus 1 from the left. You know the respective formulas. For the right limit of this, okay, where 1 from the left, minus 1. Oh, they're asking you to check only at x is equal to 1, not x is equal to minus 1.
Right one.
Why didn't they ask only, why are they asking only this? Okay, let's do 1 first. So you know the formula is f of 1 plus h minus f of 1 by h, limit h tends to 0. And for the left limit of the same one is f of 1 minus f of 1 minus h by h, limit h tends to 0. I am only doing it for this one. Okay, so what is 1? 1 plus h means greater than 1's formula. Greater than 1's formula is 2x. So 2 into 1 plus h, because f of 1 plus h, minus f of 1. At 1, what is the formula? The answer itself is 2. At 1, the answer itself is 2, because we have done it at 1 and minus 1, the answer itself 2. So 2 by h. So what you do, you can take the 2 inside, 2 plus 2h minus 2 by h, where 2 and 2 get cancelled. So answer will be 2 for the right hand limit. Let's go to left hand limit. What is f of 1? You know the answer is 2. Minus, what is f of 1 minus h is minus 2x. So it's minus of 2 into 1 minus h. Minus of minus will become plus by h. So 2 plus 2 minus 2h by h. So it's 4 minus 2h by h. And the limit h tends to 0. You don't know what to do about this, keep it like this. And is equal to, is not equal to definitely 2, right? So then can we just write this and say that it's not differentiable at plus 1? You know that this point is not differentiable. You're just simply trying to justify it, and you justified it. You got a cramp here, but let it be, correct? So unless the 2 was getting cancelled, it wasn't getting cancelled, no? Because f of 1 minus h was f of 1 minus h. No, f of 1 minus h is also 2. You have to see this, because we are not approaching minus 1. f of 1 minus h is also just 2, correct? Shit. F of 1 itself is 2. Less than 1. What is less than 1's formula?
Less than 1 is 2.
Less than 1 is still 2. 2 minus 2, 0 by h. 0 by h is not equal to 2. Oh, we made a mistake there. I hope you can correct. Everybody is understood, because I can't redo again. It will become very difficult, but people can follow, no? So make sure you're correcting this. And so it's definitely not differentiable. And you know, for that matter, let's do this sum. Minus 1. So let me rub this, okay? And you know we can do it for minus 1 also with the same confidence, correct? So you're going to write the formula, which is right limit f of minus 1 plus h minus f of minus 1 by h. Limit h tends to 0 is for the right hand limit, and f of minus 1 minus f of minus 1 minus h by h. Limit h tends to 0 for the left limit. So what is f of minus 1? F of minus 1 is a 2. That's where we shouldn't make a mistake. So it's 2 minus f of minus 1 minus h, means approaching minus 1 from the left is minus 2x. Minus of minus will be 2x, which is 2 into minus 1 minus h by h, which will be 2 minus 2 minus 2h by h. This and this get cancelled. So minus 2 is your left hand limit's answer. For right hand limit, f of minus 1 plus h greater than 1's formula itself is 2. So then the minus 1's formula itself is 2. So 2 minus f of minus 1 is also 2 by h, which is 0 by h, and this is not equal to this, and hence it's not differentiable. How is it? Clear? You understood the sum? So you know for the fact it's not differentiable. I'm just trying to justify it, okay? So let's go to next question, which I wanted to try. Okay, we can do this sum also. Check whether it's differentiable. So then the next sum is f of x is equal to, just open the bracket, x when x is less than 1, 2 minus x if x is lying between 1 and 2, minus 2 plus 3x minus x square when x is greater than 2. So in this sum, come left side of 1 answer is x, so differentiate that to 1. Right side of 1 answer is 2 minus x, differentiate it to get minus 1. So left hand limit will not differentiable. It is not differentiable. You know practically it's, but you have to do it as a sum. So then limit of what is the form? Okay, left hand limit. What is the formula? F of 1. Now we can directly find the formula. F of n 1 minus f of 1 minus h by h limit h tends to 0. Purida? Ipo direct get aita. Right hand limit is f of 1. F of 1 plus h minus f of 1 by h limit h tends to 0. So f of 1 at 1 the answer is 2 minus x, which is 2 minus x is 1. So answer is 1. Minus f of 1 minus h is less than 1's formula, which itself is x, which is 1 minus h by h. So 1 minus 1 plus h by h. So answer is 1. We know differentiation of left side is 1. You know x differentiation 1 beautiful. So let's go to right hand side. 1 plus h. 1 plus h means greater than 1's formula, which is 2 minus 1 plus h. Correct? Minus f of 1. F of 1 is just 2 minus 1, which is just 1 by, this is one term, by h. So open the bracket, 2 minus 1 minus h.
Minus 1 is
1. 1 and 1 get cancelled. Minus h by h. The answer is minus 1. You know, left hand limit, you know that this is going to be minus 1 and differentiated also. We're getting a pakka answer. So let's now do the differentiability for 2. We just tried the differentiability, checking the differentiability at x is equal to 1. Let's try the differentiability at x is equal to 2. So left hand limit, what is it? F of 2 minus f of 2 minus h by h. And for here, it's f of 2 plus h minus f of 2 by h. Limit h tends to 0 and limit h tends to 0. And what is f of 2? At the point 2, it's 2 minus 2. 2 minus 2, it will become 0. X will 2 f of 2 now. So it will become 0 minus f of 2 minus h. Less than 2's formula. Less than 2's formula, 2 minus x. So it's 2 minus 2 minus h. This one term by h. So open the bracket. 0 minus.
0 minus h.
This is within the bracket. No, 2 minus 2 minus h has to be within the bracket. So it's 2 minus 2 plus h. So it will be minus h by h. The answer will be minus 1. Right hand limit is 2 plus h. 2 plus h is greater than 0, greater than 2 formula, which is this whole graph. Oh my god. Minus 2.
Can be factor.
Minus 2. Minus 2 plus 3 into 2 plus h. Wherever x is. Minus x square. Minus 2 plus h the whole square. This is the formula for f of 2 plus h. So let's solve this first and write the answer. Minus 2 plus 6 plus 3h minus, let's expand this, 4 plus 4h will become minus 4h minus h square. So let's solve it. This is plus 4 and minus 4 gets cancelled. This is minus h square, isn't it? By h. Correct? We have only solved for f of 2 plus h. And what was the answer for it? It was minus h square by h, where you could have taken h out common and cancelled also. If you take h out common and cancel, it will be minus 1 minus h. That's all. That's the answer, correct? So then therefore write it as minus 1 minus h, the answer for this, minus f of 2. F of 2. At that point 2 minus 2 will be 0. So then 0 by h. So it's minus 1 minus h by h. And you know for the fact it's definitely not differentiable. Just leave it like that. Correct? And that's about this point. And when differentiability sums, this should be your approach. Are you clear? So that's enough, guys. That should be enough. I've done enough number of sums for differentiability. And the greatest user function, let me do this sum. The last sum for the day for you, like they've given f of x is equal to greatest user function of x. Okay, you have to check. You know that it's not continuous at 1, 2, 3, all integers. Any greatest user function is not continuous, so it will not be differentiable also. So if they ask you if it's continuous, and write about continuity, we know that it is not continuous at x is an element of integers. Therefore, it is not differentiable also at x is an element of integers. Do you think so? No. Let's do the graph. It's fill, don't fill. Fill, don't fill. Fill, don't fill. It's differentiable nowhere. Even if you do a slope here, it's only parallel to x-axis. Parallel to x-axis means tan 0. Tan 0, 0. You don't have a slope anywhere. It's not differentiable at not z. X is an element of all real numbers. It's not differentiable. You agree with me? So that's about this, and that's what I would write. And I wouldn't go about proving it, because when it is not continuous, I don't have to prove for differentiability. It will obviously not be differentiable too. So leave it like that. And that's all, guys. So I've just given you an idea of what differentiability is all about, and we'll do more sums later.